So now we're going to look at this set, which is just like the other one, except I'm just using omega, okay? And we got 4 here and 9 here. Now people guess, well, that's going to give you an ellipse, and that's correct. Easy to prove. So if r of t is this, xi plus yj basically, it's easy to prove that your path is x squared over 16 plus y squared over 81 equals 1, and that path is an ellipse. This doesn't tell you what the velocity and acceleration vectors are, okay? But the path itself is an ellipse. And it also, you know, you get all the way around the ellipse when omega t changes by 2 pi, right? So the period is 2 pi over omega. Very simple. If t changes by 2 pi over omega, then the argument changes by 2 pi. So you want to kind of keep that idea in mind instead of memorizing formulas like engineers do. And then they confuse them. But then they've got their handbook, but they waste time going to the handbook so when they forget the formulas. Of course, if they're using them a lot, that's not a problem, okay? But the whole point is there's a simple principle in figuring out the period of this thing, which I think you guys understand. Okay, so let's see, I've got 4, 0, a little too far over this way. Now that I look at it. Okay, now to graph this ellipse, just lightly, I'm going to graph horizontal line here, horizontal line here, vertical line here, vertical line here, so I've got a rectangle. And now to graph the ellipse, I just inscribe it inside of this rectangle. Okay? That's how I teach people to draw ellipses. It's also convenient if you have a minus here. Okay? Which would, well, in this case it wouldn't, okay. If you have a minus here. Gives you a hyperbola, and the asymptotes of the hyperbola will be the diagonals of this rectangle. Very easy picture. Okay, and there are other easy pictures with conic sections. Now that's a digression. Here's your path. And it's pretty clear that you're here at t equals 0 and at t equals 2 pi. Two pi over omega plus 2 pi n. No, sorry, 2 pi over omega times any integer n. Got a little fancy there, okay? In other words, n being a natural number or an integer, okay? And I'm not going to specify that. It just means if you go around this thing 78 times, you're still going to be here, right? Okay? And then, you know, the times when the position is at the different, when the r vector is at different positions, okay? Now let's just say the r vector is someplace convenient. We'll put it here. Then what's the direction of your velocity vector? You have a point moving around here that stays with the tip of the r vector, right? So the question is, what's the direction of your velocity vector? And then what's the direction of your acceleration vector?